Alright, so in the last video I talked a little bit about problem 2 and 3. You need to draw in the shapes, and the table is shorter than the parallelogram table, and that's all about that first question, number 2. Should all the parallelogram conjectures work for rectangles? And hopefully you said the answer is yes. And the reason why is because all rectangles are special parallelograms. In other words, every rectangle fits the definition of parallelogram. Parallelogram by definition is a quadrilateral, which a rectangle is, that has two sets of parallel sides, and every rectangle has two sets of parallel sides. So therefore, if the conjecture works for a parallelogram, it has to work for a rectangle, because rectangles are special parallelograms. So the 5 things that are no in problem number 1, those are the 5 things that you were supposed to investigate for rectangle. So in a rectangle, I'm going to go ahead and just label these A, B, C, and D, if I be consistent with my labeling. The question that's being asked here is, are the adjacent sides congruent? And if the answer is yes, then you're supposed to write the equation, just like we did the parallelogram. The parallelogram, and so that you know what things are actually congruent. And you're supposed to also mark the picture to show that. So rectangles all have 4 right angles. So I'm going to go ahead and mark the angles. Alright, so the first one is, again, are the adjacent sides congruent? And the answer is no. AB and AD don't have to be the same length. They can be if it's a square, but there are lots of cases where it's not true. Are the adjacent angles congruent? And that answer is yes, because if I choose any 2 angles, they're the same numbers, because in a rectangle, all 4 angles are right angles. So angle A and angle D are equal. Angle A and angle B are equal. Angle B and angle C are equal. And angle D and angle C are also equal. So you have 4 pairs of adjacent angles. The diagonals, so it would be AC and BD, were they the same length in the investigation? And hopefully you found that answer to also be yes this time. So AC and BD are always the same length. The next question or investigation was, if I look at the diagonals, are the diagonals perpendicular? And this answer here is no. And then the last one, if I look at the diagonals, do the diagonals cut angle A in half? In other words, are those 2 angles always 45 degrees? Same thing for B, C, and D. Do the diagonals cut the 90-degree angles into 45s? And the answer here is no. So of the 5 things that the parallelogram has as being a no, 2 of them work for a rectangle. So go ahead and move on to the Robbins investigation. And again, when you're finished, turn the video on to check your answers to problem 3 and the table.